All right. Thank you, Lauren. So I'm Jason Patton. I'm with the CHTC here at UW-Madison. And as Lauren was saying, I'm going to talk about how we've been using some information from users' jobs to try to here it says increase Goodput, but there's some other things that we've been trying to do with this as well. But first, I'm going to go sort of back to the black and white days of how we try to track usage of our Condor pool or pools in CHTC. And we did this by going to the negotiator and asking for basically all the accounting data you have since the beginning of time. And we do this every day, and by tracking it every day, we can see what's going on over time. But this accounting data is kind of these accounting ads are kind of difficult to work with. You can see that when I ran this, there was over 100,000 attributes in this class ad that comes out, and the formatting of it is such that you have to have like this unique identifier per user, or I guess per submitter, and then find ways to correlate that number across all the different types of data that are in this class ad. So we do this every day. We grab this accounting ad, crank it through our machinery, and out pops this somewhat useful information, which shows the total amount of CPU hours that was used in each pool per day. Just so you know, going forward, whenever I show some of these charts these tables that we make, I'll have the identities redacted to spare the innocent parties involved here. But you can see that for this particular day, we had almost a million hours of CPU hours that we provided to all the different pools on campus here. So that's nice and all, but it kind of leads to some questions. Of those million CPU core hours, was any of it actually good? Did any of it contribute to science? Nothing in that list of projects really says, well, this amount of jobs were removed, this many jobs went on hold, et cetera, et cetera. And then this is only showing CPU usage. It doesn't tell us anything about these other resources that we provide, like GPUs, memory, file transfers, all these things that the people that pay us all these big bucks to put these computers and resources together might want to know. And then it doesn't also tell us anything about the user experience. Did any people's jobs go on hold? Did they have to go through and remove a whole bunch of jobs because there was something weird with some machine that was causing their jobs to get wedged? None of that shows up in the sort of old usage reports that we used to have, or that we still have, but that we want to improve upon. So taking a quick detour, I'm going to talk about a tool that we've recently added to Condor, or to the HTCSS, called Condor Ad Stash. And what this does is it pulls all the access points that you pointed to for job history, and then shoves all of that into an Elasticsearch database. And immediately from doing this, we get a couple of wins. We now have a very quickly queryable database that has a history of all of our job ads. Just note the asterisk there. We'll get to that in a second. Whatever users are putting in their job ads, because Elasticsearch is not a table-based database system, you can still have new attributes that weren't previously defined. Those can get all shoved in there. It'll be there for you to query as well. There are libraries available in popular languages. I'm mostly familiar with Python for querying Elasticsearch. So you can use that to develop reports, whatever you want to do with this data. And then you also get a nice web UI using the Kibana web app, where you can do some simple queries and graphs, and it's very helpful for when you are developing with some of these other programming language libraries. But there's some gotchas too. So because Condor Ad Stash uses the HT Condor Python bindings, These technically count as remote history queries when it's pulling all of these access points. And it turns out that we, by default, limit remote history queries to the last 10,000 ads that a SCED knows about. If you're curious, it's this knob if you want to go in and change it in your pool. But that means that because there's a limit on how many ads you can get at a time, if you have a very busy access point, you may miss out depending on how often you're querying for these ads. Or if some kind of outage occurs where Adstash goes away for a little bit, again, you may miss out on some ads. Another issue is unlike class ads, Elasticsearch is a little bit more malleable than a lot of databases, but not to the point like class ads. The field names are case sensitive in Elasticsearch, which is different from class ads. And field values must all have a given type. And so we work around this by having Adstash convert any unknown attribute names that we don't usually stick like in a job ad. We convert those field names to lowercase because users are apt to put, want, let's say want flocking in all caps or want flocking in all lowercase or camel case or what have you. And these would all show up as different fields in Elasticsearch if we didn't do some kind of normalization. And then we make any unknown fields also just to be text because, again, users could stick in an integer one day and they could put in a Boolean the next day or whatever. We just want to make sure we have whatever the raw value is that they put in there. And then the last thing is just kind of more of a personal rant. Elasticsearch, these library tools that I mentioned are so helpful. They will break those without much warning. For example, if you try to use Adstash with the latest version of the Python libraries for Elasticsearch, it won't work because they break something as simple as connecting to the database in 8.0. Okay, so all that aside, we have all this wonderful job data that's stored in Elasticsearch. Now what? Well, I'm going to go back to one of the early slides, and instead of doing usage reporting with accounting ads, let's talk about doing usage reporting with Condor Ad Stash. And so let's see if we can try to address this very first question. Was any of our usage actually good? I'm not going to talk about the exact same day in these next slides, but just the general idea. Was any usage good that we had? So let's try to actually define what we mean by good. And helpfully, I've put the definition here of Goodput as the opposite of bad put. All right, so what's bad put? The opposite of Goodput. Bad put is we're saying any sort of claimed computing resources that did not actually contribute meaningfully to a requested computing task, or since we're mostly all here to support science, you can just think of it as any task, any computing resources that do not contribute to science. So this is one of those things that's easy to define by words, but how we actually do this is a little bit, it gets a little tricky. All right, so I know that Marone just talked about how we shouldn't always just think about CPU hours or make that our initial thing. So, but we're going to talk about CPU hours right now. So what actually makes for good CPU hours? This is kind of, again, defining it toward using the, we might know a little bit better about what bad means. So we just take the total minus the bad. So what should actually count towards bad CPU hours? Again, when basically any time that science isn't being usefully done. But trying to put this more towards Condor terms, we're going to say it's the time spent by any job execution that didn't exit on its own accord or didn't exit due to some specific user action. Most clearly, this would be evicted executions. The admin wants this computer back, or you're running on opportunistic resources, or the admin just goes and trips over the power cable, and there goes your server. But then the question comes up: oh, what about help jobs and remove jobs? Do these contribute to bad put always? As a show of hands, I'm just curious, if a user removes a job, do you consider that all to be bad put? Is that all good put? Or does it depend? All right, so for the people on Zoom, if you didn't see, most people that cared to take part in this this exercise says it depends. So we have to draw the line somewhere. And our assumption is that good CPU hours are CPU hours that were used in the very last execution attempt of a job. So maybe a job restarted a few times. We're only going to count that last time the job started and then ran to completion as good CPU hours. So all that said, there's a lot of words here. Can we actually calculate Goodput from a job ad? So if we go and look at all the attributes that a job has, from all the stuff that we've shoved into Elasticsearch so far, we've got over 1,000 fields to choose from to try to calculate Goodput. Okay, so we're going to need to narrow that down a little bit. Well, at least if I go and look at some jobs that were recently in history, it narrows it down a little bit. Hopefully we can use the one of the 167 or multiple of the 167 attributes that showed up in a job to calculate this. So there's a nice page on page 490 of the HTTP Condor manual that actually lists what most of these job attributes are that are in a job class ad. But fortunately, everyone here is already an HTTP Condor expert, so let's just jump into a quick pop quiz. Which pair of attributes provides the total runtime across all the jobs runs and the runtime of this job's final run that we care so much about for calculating Goodput? Is it remote wall clock time, committed time, or flip-flop those? Remote wall clock time, last remote wall clock time, or again, the inverse of those? I'll give you a second to think about that. All right, so anyone that thinks it's B, or sorry, thinks that it's A, yes, but there's a catch. Committed time does usually refer to the runtime of a job's final run, but it's undefined if the job gets removed. So that's not very useful if we want to also calculate count removed jobs as potentially having Goodput. So how about C? Well, yeah, that actually works for removed jobs, except that it's a very recent addition. It only came in HTTP Condor 9.4.0. So if your pool contains some older some access points that are running older SCED-Ds, then this may not actually show up in your ad. So we just kind of have to work with what we have and do the best we can. So I'll get to that. So the current approach is the total CPU hours. There's still a little bit of hand waving here, but it's basically the number of CPUs a job had times how long it ran, and the total amount of time that a job ran is in this remote wall clock time attribute. For good CPU hours, then we have to make some choices. If we have last remote wall clock time, we should probably use that. If we have committed time, then we'll use that. Otherwise, it's probably the job got removed or something else weird happened with it. So we're just going to say it was all bad, but there was 0 good CPU hours. And then finally, we can calculate Goodput. We like to do this as a percentage. So we take the good CPU hours divided by the total CPU hours and multiply by 100. Now you could actually say here for remove jobs, we have some other attributes if you're very intimately familiar with job class ads, like entered current status and job current start date. But then what happens if a job runs for 1 minute and then goes on hold for an hour and then gets removed? Well, the job current start date would have been, over an hour ago when the job, and then, a minute later the job stopped running. Well, entered current status is going to be when the job was removed. So now you have like about an hour of runtime. Yeah, that doesn't work either. So we just go with 0. So we do this, and we do a lot of other calculations with a bunch of other usage information, and we get this out. And I'll highlight the good CPU hours here. So on this particular day that this table was generated, we had about 80% good CPU hours across all of this would have been the OS pool. Is that good? Is that bad? I mean, I would say, in general, this is probably one of our better days, but is it good enough for our admins at the OS pool? Is it good enough for the NSF? Is it good enough for, all of us who pay taxes? That's kind of up to you, but the idea is we at least have this now, and we can see, how things are trending. Can we make things better? And then I mentioned before, we might be interested, and I think Rome made it quite clear that we're interested in more than just CPU hours. So can we do anything else? And the answer is, of course, we have all the information from the jobs. So we can create GPU
one quick comment that I think is sort of important, that when we go back to the Goodput, today the research computing facilitators are looking at this data daily, and it helps them understand what the users are doing on the system. So they can identify changes, they can identify anomalies, and the important part here is that this is a report that goes to the facilitator, so they have a better understanding of what users do. It's not an administrative tool, it's not an accounting tool. It is the tool for them to follow up and to say, did you have a bad day yesterday? Or why did your jobs behave this way or the other way? And it improves it for everyone. And I think that that's an important part of the message of this whole thing, is that it's being used by the research computing facilitators, not by the administrator.
Yeah, thank you, Maron. Actually, kind of stealing my thunder a little bit. That's okay. That's okay. Yeah, so we can generate reports for GPUs, memory usage, file transfers, and these are all things that we are working on right now. But to kind of jump ahead to Maron's point, how was the user experience? This is one of the biggest things that I came up here and talked about. This is Goodput. We want to have this so that we can report to the people that pay for these machines. We've actually done good things with it. But one nice thing that has come out of this is this report goes to the facilitators every day, and they can go and they can find users that are having a bad time. So maybe we're looking at this report, we scan down the list of good CPU hours, and we see, most people are at 80 or above, but this user was only around 60%. What's going on with that? And as we scroll down the table a little bit, we see that they had a whole bunch of jobs that executed more than once. That's a little strange. So this gives the facilitators an opportunity to go to this user and say, hey, we know that something was up. Do you know anything about what's going on with their jobs? Maybe there's even a case where we notice this before the user even notices something's going wrong. Just to give another example, maybe things look good under good CPU hours, but then we notice, this user had a whole bunch of their jobs removed. What's going on with that? So again, we can follow up with the users. And then one final example, not only do we care about CPU hours, Goodput or remove jobs, but we can also now have information about the number of times the job has been held. We can ask users, do they know why their jobs are going on hold? Is there something we can do to help? It's not necessarily that the users meant to do something wrong. I mean, maybe they tested on a small batch of jobs and there was something about scaling up that just didn't quite work out right. So it's always good to have this. We can kind of preemptively follow up before they go through and use a bunch of resources that don't end up doing anything useful. Just to note, this is just showing one report. We have additional reports that we can make. We talked about, it's not clear whether or not held jobs or removed jobs are Goodput or badput. So we can just create reports for those jobs themselves and then dig in a little bit more and see what's going on with there and see if there's anything we need to follow up on. All right, so we've covered now using all of this information that we put in Elasticsearch. We can get Goodput, we can ask about other usage and even follow up with users and make sure that they're having a good time. One other thing that's come out of this is we've improved HD Condor, depending on if you think shoving a whole bunch of more stuff in the job class ad is improving it. So things like last remote wall clock time that I mentioned before has gotten put in there. We've got now number of holds by reason in the job class ad in this nested job ad. I think this goes along with TJ's talk earlier about GPUs, where he was introducing nested class adds. We can use that for other things than GPUs. So now we have an idea of how many, if a job went on hold multiple times, why did it go on hold for download problems? Why did it go on hold because the user had a periodic hold expression? How many times did the user itself actually run Condor release on it, or Condor hold on a job? And then one thing that we're really getting into now is transfer stats, file transfer statistics. So we have, not just the total number of files transferred, but by protocol, how many files were transferred, how many bytes were transferred, and so on. There's a couple of remaining challenges. So one thing that's a little tricky is that we really only have good information about sort of the cumulative statistics of a job and maybe the last run of a job. Anything that happened in between, so like if a job restarted a whole bunch because it landed at a bad site, I know site is poorly defined, but just bear with me here. We don't have a lot of that information about what happened with the job while it was on these bad sites or whatever. And then to Brian's point earlier, how do we determine if jobs are actually checkpointing correctly? We can throw a column in our list that says, all these jobs look like they're doing checkpointing, but we don't really have any information about whether the checkpointing is actually working correctly or not. So do we really want to count everything that a checkpointing job that may or may not actually be doing checkpointing correctly? Do we want to? Don't know. All right, with that, I want to thank you, and I'm happy to take any questions.